Far from Earth, something extraordinary is happening. The interstellar object, 3I Atlas, is emitting a metal alloy never seen in nature, a refined compound typically produced only in human industry. Observations from multiple telescopes, including Hubble and James Webb, also show an unusual sunward jet, contradicting everything we expect from comets. These bizarre findings are fueling a major scientific debate about its origin. Is it a natural wonder from a truly alien star system or something else entirely? In this video, we'll break down exactly what was discovered, why it's such a big deal, and what the next wave of observations could reveal. In July 2025, astronomers spotted 3I Atlas moving on a hyperbolic path through our solar system. It wasn't just another rock from deep space. It immediately stood out for its massive size, strange chemical emissions, and unique activity. By August, observations from the Keck Observatory revealed something never before recorded in space. Atlas was spewing out about 4 grams of nickel per second, but with absolutely no detectable iron. This is a huge anomaly. In every other comet we've seen, nickel and iron are always found together in similar amounts. Further analysis identified the compound as nickel tetracarbonyl, a substance known on Earth only from industrial processes like creating aerospace coatings and specialized manufacturing. Finding this molecule around a natural object is completely unprecedented. At the same time, Atlas showed off another strange feature. It doesn't have a typical cometary tail. Instead, a jet of material is pointing directly toward the sun. And this isn't some optical illusion caused by our viewing angle. Multiple instruments have confirmed its orientation. This bizarre jet is made mostly of carbon dioxide and water, with traces of cyanide and those weird nickel compounds, but still no iron, reinforcing the chemical puzzle. To make things even weirder, Atlas has a CO2 to water ratio of about 8:1, which is among the highest ever observed for any comet-like object. On top of all that, polarization measurements show extreme negative polarization. This tells us that its dust grains and surface scatter light in a way totally unlike any comet we're familiar with. There's a lot more data on the way. Images from the Mars Reconnaissance Orbiter's HiRIC camera, taken during its early October flyby, are expected to shed more light on its structure and that mysterious jet. Unfortunately, their release has been delayed by a U.S. government shutdown, leaving the scientific community anxiously waiting for this crucial data. Put together, these chemical, optical, and physical anomalies make 3I Atlas one of the most intensely watched interstellar objects in history. The detection of nickel tetracarbonyl is really at the heart of the intense debate surrounding 3I Atlas. This compound simply doesn't form naturally under conditions we've observed anywhere else in space. Its presence is forcing scientists to completely rethink how interstellar bodies might evolve chemically over millions or billions of years. The leading scientific interpretation is that Atlas is a natural object that formed under extremely exotic conditions we've never seen before. One hypothesis suggests it originated near a carbon dioxide ice line in its home star system, where the distribution of iron and nickel might be very different from our own solar system. Over eons, exposure to interstellar radiation could have selectively altered its composition, allowing nickel to turn into a gas while iron remained locked inside the nucleus. In this scenario, the compound might be produced through rare but natural chemical pathways that are triggered by the sun's heat. However, a more provocative hypothesis has been proposed by Avi Loeb of Harvard University. Loeb argues that the combination of a sunward jet, refined metal emissions, and its precise trajectory is very difficult to explain through natural processes alone. He raises the possibility that this unusual alloy could be a technosignature, a clue pointing to a non-natural or even artificial origin. Of course, most of the scientific community remains cautious. As they say, extraordinary claims require extraordinary evidence. And the current data, while very strange, is not yet conclusive. Several teams are now conducting lab experiments to see if natural reactions under simulated interstellar and solar conditions could produce similar emissions. That sunward jet just adds another layer of complexity. Typically, the solar wind pushes gas and dust away from the sun, forming the familiar cometary tail we all know. Atlas defies this, streaming material directly toward the sun. Since we know it's not a trick of geometry, researchers are exploring whether the specific composition or grain size of the ejected material could explain this reverse dynamic. The polarimetric data seems to support this idea, pointing to fine-grained, possibly compact surface dust, unlike the fluffy material on familiar comets. This unusual structure might influence how the jet behaves and how sunlight interacts with it. Regardless of which explanation turns out to be correct, Atlas has already expanded the boundaries of what scientists thought was possible for interstellar objects. Whether it's an exotic natural phenomenon or something truly out of the ordinary, it's forcing us to develop entirely new models to explain its behavior. The implications of these findings extend far beyond this single object. For planetary science, Atlas provides direct evidence of material from another star system that doesn't fit our known chemical models. Nickel without iron challenges our core assumptions about how metals are distributed when planets form. If this holds up, it could mean there are star systems with different temperature, gradients, or elemental separation processes than the ones that shaped our own solar system. This fits into a larger pattern we're starting to see. Every interstellar visitor we've observed so far has been unique. Oumuamua showed strange acceleration without a visible tail. Borisov looked more like a typical comet. And now Atlas is massive, chemically bizarre, and dynamically unconventional. This diversity suggests interstellar space isn't filled with just one type of object, but a whole spectrum of bodies, each carrying the unique chemical signature of its home system. For observation strategies, Atlas highlights the critical value of rapid multi-wavelength follow-up when these objects are discovered. Spectroscopy, polarimetry, and high-resolution imaging were all essential in identifying its unique behavior. Future surveys will likely apply these techniques much earlier in an object's visit. The technosignature discussion, while speculative, is also instructive. Atlas demonstrates how natural phenomena can produce signals that might look engineered at first glance. This has practical implications for how we evaluate future discoveries, reminding us to maintain rigorous scientific standards without dismissing anomalies too quickly. Looking ahead, several key milestones are on the horizon. The high-RISE imagery from Mars should provide incredible insight into the jet's structure and the surface of Atlas, helping us test the competing theories. Continued observations from Keck, James Webb, and other telescopes will refine our measurements of the nickel emissions and track how the jet evolves as it moves away from the Sun. Plus, the Vera C. Rubin Observatory will soon come online, dramatically increasing the detection rate of interstellar visitors. This will give us a much larger dataset to compare against Atlas. If the nickel without iron anomaly holds up under peer review, it could reshape entire fields of astrochemistry and planetary formation theory. If it's explained by exotic but natural chemistry, it will still mark a major expansion of what we know is possible. The 3I Atlas object has defied all our expectations with its strange jet, its unique metal emissions, and a chemistry unlike any known comet. Whatever its true origin turns out to be, it's already reshaping how scientists study the visitors from deep space. The next observations may not just solve the mystery of Atlas. They could redefine what we think is possible out there in the cosmos. Thanks for watching. If you found this as fascinating as we do, be sure to like this video and subscribe for more deep dives into the mysteries of space.